Hello again. I just want to do a couple of videos based upon transition metal catalysts. Now, transition metals are very effective catalysts because they can change they have multiple oxidation states. So for instance, if you've got iron 2, it can be converted into iron 3, and then it can be converted back into iron 2. And this is essentially how transition metal catalysts work. Now, I'm going to split the video into two. First of all, I'm going to show the generic way in which we can show that transition metals are effective catalysts and how they the action they have upon a reaction. So how they speed up the rate of reaction. So I'm going to show that in general terms off page 22, and then I'm also going to do the next one on heterogeneous catalysts for vanadium 5 oxide. Then I'll do a separate video on the homogeneous catalysts. So just going to go through this action of transition metal catalysts and explain this. Now imagine we've got this reaction here. So this is our reaction, and we've got sulfate 4 ions. They react with oxygen and they get converted into sulfate 6. Now that reaction occurs, but that could also potentially be catalyzed by a transition metal catalyst. And we're going to look at either cobalt 2 or cobalt 3 plus ions. Both of those will potentially catalyze this. Now, as to whether they do, I don't know. This is an example of how we can show that these potentially would. So that's our equation. That reaction occurs without the aid of catalysts, but we're going to show how a transition metal catalyst would be able to speed that reaction up. So if we supplied with these two species here, these are our catalysts. The first thing we want to do is we want to write out what the redox reactions would be to convert cobalt 2 into cobalt 3 and then vice versa. So if we were converting cobalt 2 plus into cobalt 3 plus, make sure your cobalt looks like cobalt and not carbon monoxide. We would need to balance it just by adding an electron here. So that's balanced, 2 plus on both sides. Now that is an oxidation. We can also convert cobalt 3 into cobalt 2, and that will be by reducing cobalt 3 and adding an electron there. So that's reduction. Now the reason why we do this is because if we start off with cobalt 2 as a catalyst for that reaction, cobalt 2 will turn into cobalt 3, and then cobalt 3 will turn back into cobalt 2 in a second reaction. But I'll show how those fit in. Now, for the overall equation, what we're going to do with this is we're going to convert each of these into the product or product. Now, what we can clearly see is that the SO32 minus converts into SO42 minus. And then we balance that using the principles of redox that we've previously covered. So 1 sulfur on both sides, they're balanced. 3 oxygens, 4 oxygens, so we need to add H2O on this side to balance out the oxygen. 2 hydrogens here, add 2 H pluses, and then we need 2 electrons on this side. Now that is oxidation. But we haven't used this. Now, when you come across this, if this is a scenario you do encounter, oxygen, convert it into water. So do O2. I'm not going to do half O2. I'm not going to deal with fractions. O2, and we'll convert it into water. Balance the oxygens 2, and then 4H plus 4E minus. and that's reduction of oxygen. Now, if cobalt ions, whether it's 2 plus or 3 plus, if they were to behave as a catalyst and increase the rate of that reaction, what they essentially do, and we see this with all catalysts, is they act as an electron shuffle. So, for instance, this reaction here, if we were to combine these redox reactions with these ones, what would happen is the SO3 2- ions would convert into SO4 2- ions and release electrons. Those electrons would then be accepted by cobalt 3 plus. So if that donates electrons, this one accepts them. So what we're doing is we're combining an oxidation reaction for the true reaction with a reduction reaction for the catalyst. So I'm going to combine this one, and I'll call this one number 1, and that one is number 1. So I'm combining an oxidation with a reduction. Now, obviously, when we're combining them, we've got to balance out the electrons. 2 of those, 1 of those, so we need to multiply that by 2. So SO3 2- plus H2O plus 2 lots of CO3 plus goes on to form 2 lots of CO2 plus SO4 2- plus 2H plus. Then, so what our cobalt 3 ions have done there is they've catalyzed the conversion of SO3 2- into SO4 2-, but our catalyst has been converted into CO2 plus. Now remember, a catalyst must remain unchanged through over the course of the reaction. So that CO2 plus has got to be converted back into CO3 plus. And this is where the next line comes in, or the next 2 reactions, because our CO2 plus gets converted into CO3 plus, but that also is facilitated by the reduction reaction of oxygen being converted into water. So we combine this one and we combine this one. 4 electrons in this, 1 electron in that, so I'm going to need to multiply this one by 4. So I will have 4 H pluses plus O2 plus 4 CO2 plus. That forms 4 CO3 plus. And just lost where I am. 4 CO3 plus 2 H2O. Now, these are our equations which show how cobalt 2 and cobalt 3 ions will catalyse the conversion of sulfate 4 into sulfate 6 ions. And that's how we get to that. Now, the other thing about a catalyst is, in the overall equation, they should never appear. And we can prove that with this. So these are our important equations here. So if asked in a question, show how cobalt 2 and cobalt 3 can catalyse the conversion of sulfate 4 into sulfate 6, they're your 2 answers there. But just to prove that if we combine both of those equations, the catalyst would disappear. And theoretically, what we should end up with is that equation. So we're going to combine both of these. Now, what we've got in these is, in this one, we've got 2 cobalt 2. In this one, we've got 4 cobalt 2. So I'm going to balance it out by making these cobalts cancel out. So I'm going to multiply the top one by 2. This will probably get very ugly very quickly. So multiply all these by 2. So 2 SO3 2 minus, can you see that? Oh, just put that there. Plus 2H2O plus 4CO3 plus, and then add all of these, plus 4H plus, these don't need to be multiplied, plus O2 plus 4CO2 plus. That provides us with, in that space, I would multiply these by 2, 4CO, oh, that's carbon monoxide, 4CO2 plus 2SO4, 2 minus, plus 4H plus, and then these 4CO3 plus 2H2O. Right, that's a bit of a mess at the moment. So what we're going to do is cancel it down. 2H2O, cancel 2H2O. 4CO3 plus, cancel out 4CO3 plus. 4CO2 plus, cancel out 4CO2 plus. 4H plus, cancel out 4H plus. So all we're left with is 2 lots of SO3, 2 minus, plus O2, goes on to give 2 lots of SO4, 2 minus. Now that's exactly the same equation as that one, except the ratios have doubled, which isn't a problem. So that goes on to prove that cobalt-2 and cobalt-3 can act as a catalyst. Now, the other thing about this is we don't necessarily need a mix of cobalt-2 and cobalt-3. We could use one or the other. If we use cobalt-3 as our catalyst, so cobalt-3 plus as the catalyst, this reaction would occur first. The cobalt-3 plus would react with the sulfate-4 to go and make sulfate-6 and cobalt-2. Then the cobalt-2 would react with oxygen to go and make cobalt-3. Or if we had cobalt-2 plus as our catalyst and no cobalt-3 plus, this equation would occur first. The cobalt-2 plus would react with oxygen, form cobalt-3 plus, then the cobalt-3 plus would go to town on the cobalt-4. Sorry, not the cobalt-4, the sulfate-4, forming sulfate-6. So we don't need a mix of both of the catalysts, we just need one or the other. And either of these equations could occur first. They can occur in either order. Okay, I was going to do the other equation, the V2O4, V2O5 one immediately after this, but I'll leave it at that point now and I'll do a separate video for that because this is running on a bit. Right, thanks a lot. Bye.